Hello everyone! So for today's video, we are going to do a video tutorial on circle area approximation using the Geogebra application tool. So this tutorial will have two parts. The first one will be constructing an inscribed polygon, and the second one is circumscribed polygon. So let's start. So this is the Geogebra application tool that we are going to use throughout this tutorial. So to do this activity using the Geogebra application tool, first we will go to View menu and make sure that Algebra and Graphics are selected. Now, we want all new objects to be labeled in this tutorial. So to do that, go to Settings, look for labeling, and select all new objects. Okay, so let's start on inscribing a polygon. So first, we will create a slider R tool, or a slider R that will determine the radius of our circle. So to do that, click the slider tool, then click anywhere in the graphics view. And in the name box, type R. Then set minimum to 0.1, leave maximum to 5, and type 0.1 in increment and click OK. So next, we will create another slider. So click slider tool and we will name it as N. Then we will set minimum value to 3, maximum value to 30, and increment to 0.1. Then click OK. So the slider N will determine the number of sides of the polygon we are about to inscribe. So now, we will create point A on the origin. So to do this, click intersect tool, then click the x-axis and the y-axis. Now we have point A on the origin, and this point will serve as the circle of the center of the circle. Okay, so now we will construct the circle. So type here circle A, comma R. So this is the circle with the center A and with the radius R. So notice that if we drag the slider R, the circle becomes larger as the value of R increases. Next, we will create the intersection of the circle and the x-axis. So to do that, we have to type here B equals R, 0. So that is the intersection of the circle and the x-axis at point B, 5, 0. Okay, now we will compute for the central angle of the inscribed polygon. So to do this, we will divide 360 by n. For example, if we want an equilateral triangle, we will divide 360 by 3, which will be its central angle. So to do that, we will type here A equals 360 divided by n and put the degree sign. So the degree sign will tell the Geogebra that A is an angle measure. Next, we will construct an angle BAB prime. So to do that, click the angle with the given size tool, click point B and point A. Now, the angle with the given size dialog box will appear. So type here A and make sure that counterclockwise is selected. Then click OK. Now, this is the central angle. Okay? Next, we will try to hide this central angle. So to do that, right-click the object and then deselect Show Object. Next, we will now construct the polygon inside the circle. So to do that, click the regular polygon, click point B to B prime, and then the regular polygon box will, a dialog box will display. We will type here n, since n will determine the, or n determines the number of sides of the polygon, and then click OK. Now, we have here an inscribed triangle since the value of n we set here is 3. So, as we drag the slider n, notice that we can inscribe different polygons in the circle. Okay, now we will compare the area of the circle and the area of the inscribed polygon. So we will set R to 5 and N to 3. Okay, so first we will show the area of the inscribed triangle. So to do that, right click the object and then go to settings. On show label, select name and value. So this is the area of the inscribed triangle. So that is 32.48. Now, if we compare it to the area of the circle with the radius r, so the area of the circle is 78.5. That is computed using the formula for the area of the circle, which is pi r squared. Okay. Now, if we drag n, notice that the area of the inscribed polygon increases. Okay. Now, how close the area of the inscribed polygon to the area of the circle? Okay. Remember that the area of the circle is 78.5. So, as we set the n to 30, notice that the area of the inscribed polygon is 77.97 compared to the area of the circle, which is 78.5. Now, we can conclude that as the number of sides of the inscribed polygon increases, its area is getting closer and closer to the area of the circle. Okay, so that is the first part of our tutorial. Okay, for the second part of this tutorial, we are going to construct a circumscribed polygon. So to do that, we need the output from the first part of our tutorial. So let's begin. First, we will set the sliders both R and N to 3. So, let's set it to 3. Okay. Next, we will construct a line tangent to point B. So, to do that, click tangent tool, then click point B and the circumference of the circle. Okay, so we have here the first tangent line. We will do that also on point B prime and point C. So, click point B prime and C. Now, we have 3 tangent lines here. Next, we will define the intersection of the first and the second tangent lines. So, click intersect tool and then click the first tangent and the second tangent. So, we have here G sub 1, which is the first intersection. We will also do that on the second and the third tangent lines. Okay? So, we have here H sub 1, which is the second intersection. So, at this point, we are going to hide those tangent lines. So, right-click the object and then select Show Object. Okay? We will also do that on the second and the third tangent lines. Okay, next, we are going to create the circumscribed polygon. So to do that, go to regular polygon tool and click the first intersection and the second intersection. Now, that will result to the display of the regular polygon dialog box. So type here N, okay? So this means that whatever the polygon that is inscribed in the circle, that also will be the polygon that will circumscribe it, because we set N as the determiner of the number of sides of the polygon. So click OK. Now, let's have the area of the circumscribed polygon. So to do that, right click the object and then name and value. Okay, so we have here the area of the circumscribed polygon or the circumscribed triangle, which is 46.77. Now, as we set R to 3, that means that the area of the circle is 9 pi or 28.26. If we compare it to the area of the circumscribed polygon, so that is almost twice of the area of the circle. Now, if we drag the slider in, okay, there is, if we drag slider in, polygon na ba kanina? Okay. So, as we drag, we have here the area of the circumscribed polygon, which is 28.38. So, as you notice, the area of the circumscribed polygon is getting closer to the area of the circle. That is also our conclusion in the about the inscribed polygon. So that's all.